Okay, we are going to add some polar graphs to what we graphed before. We're going to add some rose curves, but just to recap, last time we did circles. This is r equals 6 cosine theta. You can see it is symmetric across the theta equals 0 line. If I change it to sine, then it becomes symmetric across the theta equals pi over 2 line. And then, of course, if we added or subtracted something, I might get a little loop in the middle if I change the numbers so they matched. You just get a little dimple in or something like that. Okay, so what we're going to do today, instead of changing what we add, we're going to change the coefficient of the theta. So right now it's 4 sine theta, makes a nice circle. If I make it 2 theta, now I have this flower-looking thing with 4 petals. And if I make it 3, I get 3 petals. If I make it 4, I all of a sudden get 8. So it's going to make a difference whether it's even or odd. So let me look if I do 3. Well, if I do 1, this is basically 1 petal. If I do 3, 3 petals. 5, 5 petals. 7, 7 petals. And if you look, this is still symmetric across theta equals pi over 2 because this is a sine function. If I do the even numbers, if I hit 2, I actually get 4. So it doubles the petals. If I change it to 4 theta, I get 8 petals. If I change it to 6, I get 12 petals. And it is still symmetric across the theta equals pi over 2 line. So now we're going to go ahead and graph these for real. The last type of polar graph we're going to do are called rose curves, which I just showed you on Desmos. Okay, if it's in terms of cosine, it is still symmetric across theta equals 0. If it's in terms of sine, it's still symmetrical across theta equals pi over 2, and we are still going to use that fact to help us graph it. The coefficient here, the absolute value of A, is going to tell me the so-called petal length, or how the maximum length of each petal. When the coefficient of theta is odd, it will have n petals. If n is even, it will have 2 n petals. So our goal is really just to figure out where's the location of one petal, how many petals are there, and how can we kind of equally space these. Okay, so let's go ahead and look at the first example. R equals 4 cosine 3 theta. Because there's a coefficient on the theta, this is going to be a rose curve. Okay. So what information do I already know? Because this is 3 theta, and because n is odd, there will be 3 petals, and they will be equally spaced. Oh, I'm having trouble spelling petals. Okay, how big is each petal? The length of the petal is going to be the absolute value of that. So it's going to be a length of 4 at the maximum value. I just need to figure out where the maximum value occurs. Okay, so I'm going to think about cosine. The maximum value for cosine is when cosine is equal to 1. Cosine is equal to 1 at 0. For example, there's other locations as well. So you can do this in your head, but what I'm thinking is I want to maximize the petal. So I'm going to set 3 theta equal to 0. I get theta equals 0. So I'm going to plug 0 into my table. And I'm going to think about what I would get if I plug in 0. I'm going to get 4 times the cosine of 3 times 0. 3 times 0 is 0. The cosine of 0 is 1. So at 0, my petal length is 4. 0, 1, 2, 3, 4. Okay, so this is actually going to represent my first petal. I know that there are 3 petals, and they all have a length of 4. So now I just have to equally space my petals to make this work. Okay, how many marks do I have? 1, 2, 3, 4, 5, 6. Okay, the way I have it scaled, I have 24 marks, which means every 8 marks is going to be a petal, because 24 divided by 3 is 8. So 1, 2, 3, 4, 5, 6, 7, 8 is going to put me over here. I could also think of this as it's 2 pi all the way around. 2 pi divided by 3 means that at 2 pi over 3 there's going to be a petal. 2 pi over 3, now at 4 pi over 3 there should also be a petal. 1, 2, 3, and the length is 4. Okay, so now let me look at this. I have 3 petals, they are equally spaced, and the length of the petal is 4. And in the table, I showed one point where the petal is maximized. Okay, let me go ahead and look at example 7. It says r equals 3 cosine 4 theta. So I can see right away the length of the petal is going to be 3. Because this is 4 theta, that's an even number for n, which is going to result in 8 petals. Okay, I just want to maximize the length of the petal in one spot. Why do I keep spelling petals wrong? Okay, because this is a cosine function, cosine is maximized at 0 because the cosine of 0 is 1. I could set 4 theta equal to 0, but then I'm just going to end up with theta equals 0. So the point I'm going to plug in is 0 because this is a cosine function. If I do 3 times the cosine of 4 times 0, that's the cosine of 0. The cosine of 0 is 1. So at my first petal is going to be at 0, 3, 1, 2, 3. And that's because this is cosine. Okay, so there's 8 petals. I need to equally space them. You could count the marks around here and divide by 8, or because some of you are sketching this without a graph, you want to figure it out ahead of time. Because the radians are round, the circle is 2 pi. If I do 2 pi divided by 8, that means every pi over 4, I'm going to have a petal. So pi over 4 should be right in between 0 and pi over 2. So here's another petal, which probably means my petal was too skinny. Okay, next I'm going to go to pi over 2, length 3. Okay, they really shouldn't be overlapping, but you know, it is what it is. Okay, let me check this. Let's see, there's a petal at 0, petal of length 3. There's a total of 8 petals. 1, 2, 3, 4, 5, 6, 7, 8. They're equally spaced and they all have a length of 3. Let's do a couple sign ones real quick. The same idea, except for the max where it maximizes is going to be slightly different, so you need to think a little bit more. Okay, I can tell that the length of the petal is going to be 2 because n is 3. That's odd, so there's going to be 3 petals. They are going to be equally spaced, but because I'm now dealing with a sine function, I want to think about where sine is maximized. Sine is maximized at pi over 2 because the sine of pi over 2 is 1. Okay, but this is 3 theta. So I'm going to say 3 theta equals pi over 2. So I can figure out where to maximize my petal at. So if I plug in pi over 6, I get 2 times the sine of 3 times pi over 6 is 3 pi over 6, which is 2 times the sine of pi over 2, which is 2 times 1. So that gives me 2. That's why I wanted to start it at pi over 6. Depending on your scale, it might look different. But for me, pi over 6 is right here. So at pi over 6, I'm going to have my first petal. The length of the petals 2. Okay, these do need to be equally spaced and there are 3 petals. So depending on how you would like to think about it, it's up to you. Since it's 2 pi around the whole thing and there's 3 petals, every 2 pi over 3 units, I should have another petal. But again, depending on how you spaced it, that might look different. Okay, so for me, that's going to be another one over here. And let's see, another one down here. Okay, and then when I look at them, there are 3 petals. They look equally spaced, and actually because this is sine, it should be symmetric across theta equals pi over 2, and it does look like it is. So that's another way you could match up the petals. Okay, one last rose curve involving sine, mainly just to get the kind of starting point. Okay, again, what do I know? The petal length is 3. Because this is 2 theta, n is 2. Because n is even, it'll be double. So instead of 2, it'll actually have 4 petals. Because this is sine, I want to maximize my petal wherever 2 theta is equal to pi over 2. So at pi over 4. Okay, I'm going to show my work to show that this does in fact work. 3 times the sine of 2 times pi over 4 is 3 times the sine of pi over 2, which is 3 times 1, which is 3. So at pi over 4, which is right here for me, 1, 2, 3. I have a petal of length 3. Okay, because there's a total of 4 petals equally spaced, I need to figure out how this is going to work. It's also symmetric. Depending on how your brain works, you can find the spots that match. Okay, and then when you're done, look at it, make sure it has length 3. There are 4 petals. They appear to be equally spaced, and this was a sine function, so it is symmetric across theta equals pi over 2.